Good morning, all of you. In the second session, second day of the 3-day online course, Environment, Biodiversity and Climate Change, which is jointly organized by the Rajiv Gandhi National Institute of the Youth Development, Tamil Nadu, and Society for Environment and Development, New Delhi, and Sri Venkateswara College, University of Delhi. So in the recap, in the first session, we are listen to the Dr. Nisha Mehdi Ratta, Professor C. Rajsekharan, Dr. Shyam Singh Bhartiyal, and Professor Rana Pratap Singh. And in the second day, the two sessions, morning and the evening. Morning session from 10 to 12:30, and evening session from 2 to 4:30. In the morning session, we are the two speakers. One is already joined to us, Dr. Chuba Jamir from the Terry School of Advanced Studies. And second, Dr. Yaspal Singh from Lucknow. So with these words, I invite our organizing secretary, Dr. Sunita Yadav, Assistant Professor, Department of Botany, Sri Venkateswara College, to formal introduce to our first speaker. Over to you, ma'am.
Thank you, sir. Thank you, sir. Good morning, everyone, and welcome to the second session. So it is my privilege to introduce and invite Dr. Jamir. She is a faculty at the Department of Natural and Applied Sciences, Terry School of Advanced Studies. Her key research expertise includes climate change adaptation, air pollution, agriculture, and food security. She did her MPhil in Environmental Sciences from Jawaharlal Nehru University, Delhi, and a doctoral degree from the University of New York, UK. Prior to joining Terry in 2012, she was at the Stockholm Environment Institute, UK, and has been an associate at the Environment Department University in the UK University. She has also served as core faculty member at the Global Center for Food Systems Innovation and also the manager for the UN Sustainable Developmental Solutions Network South Asia Regional Center. Currently, she is also co-leading the Mountain Agriculture Thematic Working Group of the Himalayan Universities Consortium. So we welcome you, ma'am, and thank you for accepting our invitation and being a part of this online program on environment, biodiversity, and climate change. Thank you so much. The virtual dice is over to you, ma'am. Thank you.
Yeah, ma'am, I think you are found the chat box.
I have not found, but I have shared with you the link on WhatsApp, so maybe you can just share that. Somehow I'm not able to find it.
Okay.
So just, but it's okay. You can share it later on also, not now.
Okay.
Since, are we good to start the session?
Yes, ma'am. Sure.
Okay. Very much for the very kind introduction. And first of all, I would like to thank Dr. Abhishek and all the organizers for giving me this opportunity to, to share with all the participants some insights on climate change and food security. I'm not an expert, but I'll share with you certain things that I have learned about climate change and food security so far. So I'm very much looking forward to you and also to interacting with all of you. So Dr. Abhishek, I think we have a 15-minute interaction session, right? Okay, great, wonderful. So let me just share my screen. Is my screen visible?
Yes, ma'am. Yes, it is visible. Yeah.
Thank you. So in case, because, it's online and we're very much dependent on technology. So just in case there's any issues with connectivity, please let me know immediately. That would be great. So as I said, today I'll just share a few perspectives about food security and climate change. And I can see from the agenda that yesterday you've had a number of sessions on climate change. So I'm sure you are now very familiar with the topic climate change. So I'm not going to speak about that, but I have added 3 slides, which I'm not going to explain, but just, to refresh our mind and bring all of us into the same ground. So first, looking at climate. So it's more of looking at the concepts and ensuring that our concepts that we have is in the similar line. So when we look at climate, WMO defines climate as the statistical description in terms of mean and variability. Variability is very important here. And so mean and variability of relevant quantities such as temperature, rainfall, and so forth, over a period of time ranging from months to thousands or millions of years. So climate can be shorter term in terms of months, or we can even, when we say climate, we can be even talking about a very long time scale. So there are various variables. Some of the key variables when we talk about climate change is rainfall, temperature, humidity, wind speed, and pressure. And then, however, all of these interact with each other. If it's if it's hot, if it's very warm, then there'll be a lot of evapotranspiration, and sometimes, depending upon the environmental conditions, it may also lead to convective type of rainfall, and you may end up getting more rainfall. So there is a lot of interlinkages, and I'm not going to go into this details discussing about this, but I decided to put this because this kind of gives us an indication of how complex climate is. Various climatic variables, and it interacts with human systems or human managed systems as well as the natural systems that are there. So when we think about climate, it's very, very important for us to look at climate as a system. When we talk about a system, we are talking about system which is made up of various components, each component having its own individual function, but they all come together to serve one function. So climate also, it's very important for us to look at it as a system. And there are various factors that influence climate. One is its own internal dynamics, as the example I gave you, very simple about heavy warmer temperatures, and that may lead to more evaporation of the surface water, or evapotranspiration, and that may lead to more cloud formation, then rainfall. So it has its own internal dynamics between the climatic variables. But there are also external forcings like volcanic eruptions or solar variations that may also influence climate. And now what we're more concerned about is the third very important factor, that is human-induced forcings. We are, because of various anthropogenic activities, we are changing atmospheric composition. We keep hearing about increase in carbon dioxide and various other greenhouse gases. And that leading to changes in the climatic or atmospheric processes. And then, of course, it's not just greenhouse gases, but land use change, cutting down of forest or other vegetation, because vegetations are very important in taking up or in serving as a source of carbon dioxide. So when you cut down forest, then the efficiency of forest as in removing the CO2 changes. So there are various activities, that leads to changes in the climatic conditions, and that's where we look at climate change. IPCC, that is the Intergovernmental Panel of Climate Change, refers to climate change as the change in the state of climate that can be identified by changes in the mean and or the variability of its properties. So the average temperature conditions or average annual rainfall or seasonal rainfall, or it could be variability of its various properties, and it can be in terms of droughts or heat waves, cold waves, and so forth. So changes that that persist for an extended period of time, typically decades or longer. So these are various changes related to climate change. So as I mentioned, the changes in the climatic conditions, could be because of all these factors that are there. So now, before we start talking about how, climate change impacts food security, let us try to look at food systems and the concept of food and food security before we start talking about the two interlinkages. So I always like, when I talk about something, I always like to start with the historical perspective first, because, that kind of gives us a good background, a good starting point. Now, when we look at evolution of food and agriculture, we go back in time to 2 million years ago. And then that's when we have roughly about 2 million years ago, where we have the evidences of the control of fire and cooking of food by humans. And then we fast forward to about 9,000, roughly 9,000 to 10,000 years ago, somewhere around that time. And then where we see the evidences of grains in the diet, the earliest evidences, yeah, and that's where there are many, many literature that puts evolution or of agriculture or starting of agriculture to about 10,000 years ago. And we should also remember the fact that, that 10,000 years ago was the end of the last ice age, mini ice age. Okay, so we had a mini ice age, and that was the end of that. So then since then we've had warmer periods. Then again, from 10,000 years ago, we fast forward to the present times. About 40 to 80 years ago, we had the Green Revolution, right? I'm putting this 40 to 80 years because I'm talking in the in global context. And so Green Revolution happened across the world at kind of different time scale. Mostly, of course, it started in the 50s, 1950s in Mexico and, US and so forth. And in India, we had Green Revolution starting in the 1960s, mid 60s. So the time is a little bit, there's a range. And so Green Revolution was, I would say, a very important event in agricultural history globally, because then we see a large-scale usage of various technologies, including industrial applications and use of pesticides and fertilizers. Pesticides, of course, came a little bit later. Initially, the Green Revolution package had the mechanization and high-yielding variety and fertilizers and so forth. But we see large-scale adoption of these by the farmers. And then we fast forward further, and that's where we see about 30 to 60 years ago an increase in the chemical manipulation of food, prepared food and fast food, packaged food. The introduction of packaged food in the global palate. We see that increasingly becoming more. Processed food also was becoming more and more. And then we had 10 to 40 years ago, globalization, the impacts of globalization. In India also, we see post-1990s, the trade, various form of trade liberalizations, and, that's where we see, presence of goods in the market, international goods in the market and various form. So that's where we see food, in the markets which are from different parts of the world. Maybe not necessarily, it's imported from some corner of the world, maybe grown just in India, but they are exotic food and so forth, so which are actually not grown in India earlier, but now we can grow because of various technology. And we see not just that, we also see foods off season. We can see, I mean, even in Delhi, like many of us will be from Delhi, so when in Delhi we see different types of fruits off season also, even vegetables as well. And all of these has been actually possible because of various technological advancements that are there. And now currently what we see, especially in the past 10-20 years, is a growth and in the presence of organic food or health food, superfood, and there's a various nomenclature that you call, but we see all these type of health conscious food being evolving, although they are having very high premium, very costly, so it may not be accessible to everybody. But you see in many urban areas, especially larger urban areas, the trend is increasing. So that's where we see now. As we look at this and as we see how food has evolved over time, food and agriculture along with it, of course, because agriculture is the main source. That doesn't mean that food comes only from agriculture. We get food from forest, in terms of wild collection of food. We get food from fisheries. Fisheries are also very important food source for humans globally. However, main source becomes agriculture. It still remains agriculture, and we see as food changes, as our dietary pattern changes, we also see agriculture changing, and it's vice versa. It is also as agricultural pattern changes, we see changes in our dietary composition. For example, during Green Revolution, and post Green Revolution, various policies promoted, production of rice and wheat, at least in India. And following that, we see a change in the consumption pattern also, people shifting towards more of rice and wheat and leaving behind the coarse cereals, which were traditionally consumed once in a while. So we see there are huge interlinkages in this aspect. Now, food system, when we look at, and it's very important, as as I mentioned, even in terms of climate change, it's very important for us to look at food system context from food system point of view. So when we look at that, we see various pre-farm activities, on-farm activities, and post-farm activities. So I'm just, categorizing it into three categories, specific categories. Pre-farm means, production of agricultural machineries and fertilizers and pesticides. Very important. We have, even in India, we have huge departments and ministries that are, dedicatedly looking at fertilizers aspects. Irrigation, loan and credit are becoming increasingly more and more important. Seeds, again, another very important sector. So these are all various activities which happens before the farm. And then we have a series of on-farm activities, animal husbandry, crops. From Indian point of view, crops are very, very important, right? And then you have dairy, fisheries, and various other aspects. And all of these are also very much dependent on climatic conditions. Then there is the post-farm activities, which are related to processing, transportation, storage, the whole market value chain, wholesale markets to retails and even restaurants. In urban areas, restaurants are becoming increasingly very, very important from, or significant from the point of view of, providing to the urban masses. Yeah. Then you have post-farm activities like consumers, household, institutes, hospitality sectors. All of these come together to form the food system. And throughout the food system, climate change impacts, all these food components in some way or the other. Yeah, irrigation, for example, pre-farm, because of maybe drought conditions and reduced rainfall, maybe it could lead to farmer needing, to irrigate the crops. Yeah, and then the farm, or delayed rainfall, the farmer then have to irrigate. So there, like that, there are direct linkages as well as indirect linkages. So if we look at the whole food system, the entire food system, and how climate change impacts, we can look at how it impacts production, how it impacts processing, food distribution, and consumption. Right, so food production, that includes resource depletion and degradation. Water is one very important aspect, right? Water availability. Now, climatic changes can lead to reduction in the surface water as well as the groundwater, and that may, that may have a huge implication on food production, or even not just food production, but even in fisheries and various other aspects. And it is not only in terms of reduction in the water quantity, but even quality also, because as wells dry up, as groundwater gets depleted, then that also then leads to degradation of water quality. Then, post-harvest, post-production, we see climate change impacting on various aspects, including processing. Processing, for example, we keep hearing in India, as as an Indian, we keep hearing about flooding taking place, especially during the monsoon season, right? In many parts of India, whether it's north, south, east, or west, whether it's in the coastal areas close to sea level or in high altitude areas in the hills, still flooding is very much present. Now, when flooding takes place, that can impact food processing aspects. Hot and cold, hot and humid conditions, for example, may require us to ensure that we are processing food in a much better way. We are able to, the food storage requirement also arises. Yeah. So all of these impacts it, and then even storage can be impacted because of flooding, say, for example, right? And then food distribution, roads get affected. There can be, because of heavy rainfall, there can be landslides, for example, especially in the hills, and that can then disrupt the food transportation or the food distribution aspect. So we see this happening even in Delhi also, right? Whenever there are rains in Himachal or Uttarakhand, then that disrupts the food transportation, especially in horticultural crops like tomatoes, and this has a huge impact because in people living in Delhi, because the prices shoot up then. So then, especially for people in the lower income bracket, the bottom pyramid, this becomes a huge issue. Any change in the food price will have huge implications on their consumption level, because much of their income is utilized for food consumption aspect, right? And then, of course, that this also can have huge impacts on food consumption. Climate change can change in food consumption due to availability impacting, the source. Food production, the food quality can be impacted because of climate change. And then when, so we may have food with lower nutrients. And when we consume that, lower quality food, then that can have implications for human health as well. So there are various direct and indirect impacts. Now, it's important for us to understand food security and how we define, and defining food security, food security is a term that we know, and we keep hearing about it, and it's like it doesn't sound like an alien word to us, but then many a times the common terms are even more difficult to understand because of the fact that different people look at it from different perspective. You see, food security, for someone who is poor, may look at it in a different way. Food security for someone maybe a nutritionist may be different. So we look at it in different perspectives. So it's important for us to again look at this and see where we are looking, how we're defining food security. So for today's discussion, I have used or taken the definition that is been given by the United Nations Food and Agricultural Organization in 1996. Of course, this definition is a few decades old, so rather a little bit old, but then this is a very commonly used definition, and therefore I've taken that. So here it says food security exists when all people at all times have physical and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. Okay, so here all the people at all the times, so it should be all the times, and access. And here we talk about meeting the dietary requirements. So there's no blanket diet for everybody. You see, you may have a very active lifestyle. You may be maybe you are a sports person. Your dietary requirement is going to be very different from many of us who are students, or people who just sits in front of the desktop in the office also, right? So we have more or less sedentary lifestyle. So our requirement, our calorie requirement is going to be very different. So for a healthy life, we will have different requirement, and we have to ensure that we have that that sufficient amount of food. And preferences is also very important. You see, non-vegetarian protein is considered as very good, but we cannot say that to a vegetarian person, right? For vegetarian, we have to see what is the best protein source. So the dietary preferences itself is very, very important. So it's a rather long sentence, so I've tried to break this down. If we break this down, we see 4 dimensions that come out of this definition. One is the availability. You see here, have access to food. Yeah, so all people at all times have access to food. So the availability, food should be available. Very, very important, right? And then accessibility, economic accessibility is also another here, economic and physical accessibility. Food utilization, the way we utilize our food. and stability, that it should be there at all the times. So we see 4 dimensions of food security. When it comes to availability, we are talking about production, whether it is agricultural production, dairy or fisheries or anything, but production of food. But then it's not necessary it has to be only production. It can also be import capacity. There are certain parts of the world where because of harsh environmental conditions, not much food can be grown. But if they have the import capacity, for example, Iceland is a place where you cannot grow that much amount of food to meet the demand, but it's a rich country, so they are very much dependent, except for fisheries and all, for the cereals and fruits and vegetables. They are so much dependent on import, but they have very good import capacity, and therefore they are able to ensure that food is available for the residents throughout the year, right? Or it could be food reserves or food aid. So there can be availability can be in various aspects. For us, most of us living in urban areas, availability means it should be there in the market. You see, that is very, very important. But then again, just because food is available in the market doesn't mean that people have access to it. You see, people may not be able to buy it. Purchasing power is very important. Affordability, all of these are very important. Or food is there in the market, but there's a lot of disconnect. This is a huge issue, especially in those people who are living in the mountainous regions, where transportation mobility is a huge problem. So to get to the market to buy food, it may be very difficult. Sometimes even, there can be landslides and there can be various other issues because of which you cannot get. Conflict-prone areas, in that you may have food in the market elsewhere, but you will not be able to go. You have money to buy, but you are not able to access it physically. And for us, many of us who are living in urban areas and younger people, food utilization is very, very important. Okay. Good, and so nutritious food, ensuring that food is nutritious. See, we live in Delhi, many of us, and we get a lot of vegetables, we get a lot of fruits, whatever we want, it is there, right? But the problem, and it says that if you eat a huge amount of vegetables and fruits, they're very healthy and nutritious and you should go. But even if you're consuming only fruits, vegetables, mostly fruits, vegetables, all the healthy fruits and vegetables, but how can you guarantee that the fruits and vegetables that you're consuming, which you have bought from the market, is safe and nutritious? First of all, it is the quality, what is the nutrient composition? Because many a times we see, for hybrid varieties, and they're not, and sometimes they might not be so nutritionally dense as compared to traditional variety. You see, let's say papaya. Okay, so papaya, if you actually go to some certain remote areas and you buy, not buy, but you pluck that papaya and have it from the tree, which are traditional varieties, then the taste is very different. And obviously we can only feel the taste, but then nutritional quality is also different. So one is nutritional value, but the other thing is safety. How can we be sure that pesticides, it is not contaminated by pesticides? How can we be sure that there will be other microorganisms, that may microorganisms on the fruits and vegetables that we buy? So food, nutritious, nutritive quality of the food safety, quality, water, sanitation, these are very, very important. In terms of utilization, it's not only that, it's not only what we get, but even if you may get, even if you may go for organic food and, the best one you are able to purchase. But if you're not having it in the proper way, if you're not cooking it in the proper way and having it, then that becomes a problem. So it's also the way we utilize it, the way we take, that itself is very, very important. And of course, many a times in many places, the availability, accessibility, and utilization is disrupted because of weather conditions, because of price fluctuations, political and economic factors. Many a times it happens to me also. We go to office and we are so busy that sometimes we skip meals, or we don't take meals at regular intervals, and Those are socioeconomic factors, and that can be a huge issue. So food security encompasses all of these. So what we're going to do is we will look at each of these and how climate change may have an impact on availability, especially availability, accessibility, and utilization. But before that, maybe Dr. Abhishek, should I take questions now, pause and take questions for a few minutes, or should I proceed and take questions at the end?
As you wish, ma'am. It is okay. If you want to take the questions now, the participants can even interact with ma'am now also.
All right. Thank you. Thank you very much, ma'am. Yes, so maybe I'll take one quick question and I'll relax from.
Okay, yeah, sure. Okay, so participants, in case you want to ask ma'am anything, you have any query, any doubts, you feel free to interact with ma'am now.
Good morning, ma'am.
Good morning.
This is Nachita, ma'am.
Yes, please.
Ma'am, thank you so much for sharing such valuable knowledge with us. And for that, I have a question.
Yes.
In food production part, you have mentioned about resources depletion and degradation.
Yes.
And in that part also, there is a point like crop preferences of farmers and change in livelihoods. So, ma'am, what exactly should be the preference of farmers, and what should they adopt in like their lifestyle for food production, and there will be impact on climate?
Yeah, this one, right? This aspect.
Yeah, yes, ma'am.
Yeah. No, farmers' crop preferences would be, for example, it can be either in terms of crop management, or it can be in terms of what crop you are growing. So you see, farmers started adopting rice as well because of the availability of technology. So what happens is that when you grow that, sometimes that can be, so that can lead to depletion of groundwater, and that coupled with climate change may have an impact, because drought conditions or delayed in the rainfall already, if the water level is depleted, then that can have impacts on the crops much more than the traditional varieties. Yeah, so it could be that sugarcane, for example, in Maharashtra, right? Sugarcane, mass production of sugarcane has led to, it is not only climate change related, there are various other aspects also, which I will mention in the next one, coming slides, but there are irrigation has led to water depletion, and when the groundwater level is very low, any changes in the rainfall, any delay in the rainfall will impact that much more. So all of these can have a huge, can influence how climate change may have an impact on agriculture and farmers' behavior as well.
Okay, ma'am. Thank you so much. And ma'am, what should be the change in livelihoods of the people? Like, what should they adopt? For food production?
This is here. I have put change in livelihood more in terms of climate change impacts. So across India, and not just India, globally, we see, especially in the warmer, drier conditions, that the changes in the temperature and rainfall, and also climate variability, has actually had a huge impact on food production, because of which they are not able to produce sufficient amount of food. Yeah, and as I said, this is not only related to climate change. In reality, there are many factors that impact. So groundwater depletion and pest and various other things. So because of which their crops can be very unproductive, and many a times it also leads to farmers abandoning the farm and shifting and moving for a different livelihood, non-farm livelihood, Or in many cases, the male and also the younger, healthier members of the family household will move to peri-urban area or industrial areas or even urban areas in search for non-farm livelihood, leaving the farm behind to women, elderly, and children. So that's just a term which we use as feminization of agriculture, where more and more, farms are being left under the management of women because of the need for livelihood diversification. So this can be one example. There are many things, but this can be one example which I can think about.
Yes, ma'am. Okay, ma'am. Thank you so much.
Okay. Great. So let's move ahead. Thanks for the question, Najda. That was really good. And I look forward to interacting more with all of you. So let's look at the availability part, right? Availability and how. Agriculture from availability, I will discuss. I mean, you have food security when you talk about that, fisheries and other things are there. But today I'll not speak that. Since there's limited time, so I'll focus on just the agriculture part. But then, the crop part is the most common form for India's context. Agriculture has been very, very important, right? It has played a significant role even in the past also, because we see agriculture as an essential component for the rise and survival of early civilizations. But in the present conditions, its significance is very high, even more. Yeah, in terms of its supplier of basic human need, that is nutrition, that has been there in the past also and now also. But now if we see large number of population is dependent on agriculture and allied sector for livelihood, especially in countries like India, then we see agriculture as world's largest user of land. The statistics shows that about or more than 1/3 of Earth's terrestrial surface is under agricultural purposes. Yeah, but this includes livestock as well, not only for crops. So which also means that if the agriculture is sustainable, then we will be able to sustain land resources, and if it's unsustainable, that will be a huge issue. Agriculture significance is also from the point of view that it is the largest consumer of fresh water. Yeah, if you see, for example, in India, statistics shows about more than 80% of fresh water consumption in India annually is by agriculture, mostly for irrigation purposes. So really huge, and it plays a very important role. Now, if we look at agriculture and how food production has increased over the years, before that, just a couple of concepts to make it very clear. Let me give you an example. Let's say if you have 1 hectare of land, yeah, you're a farmer and you have 1 hectare of land, and you're growing rice during the monsoon season, and your yield, you're able to produce 100 kgs of rice. Yeah, so I've used 100 so that it's easy for us. Now, if you want to increase your production or farm production, what you do is you take 1 more hectare of land. So you have expanded your agricultural land, and because of which now you're getting 200 kgs of rice. Okay, so this is in an ideal situation. So I'm just using the straightforward. Now, this type of increasing food production is known as extensification. Yeah, increasing food production by extensification. But many a times expansion of land is very difficult. So what you do is you decide to increase cropping intensity. So what you do is you grow rice in monsoon season, and then winter you kind of leave the land fallow, and therefore you decide to grow winter crop, wheat, in the winter, and therefore you get about 100 kg of wheat in 1 hectare in winter, and then you get again the same thing, right? So you have doubled without actually increasing the land expansion. And you don't necessarily need to do that. You can also, what you can do is you can also increase the yield in that 1 hectare by increasing inputs, maybe by irrigating. If if your crops are facing water shortages, irrigation, you can apply fertilizers so that your crops are well, receive good amount of nutrients, pesticides. You can use high yielding varieties, and then increase your rice production to 200 kg or any number, right? You can increase the yield. These type of increasing food production is what we normally call as intensification. Okay, so there are two things. One is extensification and the other one is intensification. So if you look at the global statistics, it's a little bit small, so you'll have to focus more in that. So here it shows this bar graph here. It is how food production has increased. And this is for different regions of the world, all developing countries, South Asia, East Asia, Near East and North Africa, Latin America and the Caribbean, Sub-Saharan Africa, and the world. Okay, and this is looking at rain-fed and irrigation. So it is showing what has contributed to the increase in crop production between 1961 to 1999. So during this time period, about roughly about 40 years, it's 40 years, right? Whether it is because of yield increases, that is this one, or arable land expansion, green one, or increased cropping intensity. So we see here very clearly that maximum in most part of the world, except in Sub-Saharan Africa, in most part of the world, the increase in the production of food has been because of increases in the yield, that is intensification. You see here, by increasing inputs like irrigation, fertilizers, pesticides, using high yielding varieties, all of these has actually led to. In fact, in many places, like for example, Latin America, Caribbean, extensification has been there. In South Asia, in our part of the world, actually, the extensification has not been so much as compared to intensification. It's actually intensification is both of them, blue and the orange, so it is like that. And in future, this is between 1997-99 to 2030. So future, it's projected that maximum increase will still be because of intensification. And there is actually very little scope for extensification, arable land extensification in most parts of the world. There are, but like places like Africa, but then again, they're having huge water scarcity. Water is a huge problem. And then, of course, there are scope for arable land expansion in Southeast Asia and Latin America, but then that is at the expense of tropical rainforest. So again, that will be at the cost of biodiversity, so that is not sustainable. Now, why I have put this here is because if you look at this, intensification, extensification also means that all of these adds huge pressure on natural resources, on the land resources, right? Because if you're growing only rice during the monsoon season, or not rice but any crop, but if you're growing crops only for one season during the monsoon season and the rest of the time in winter you're leaving it fallow, then the amount of water utilized by the agricultural crops is not so much as compared to if you're growing crops in monsoon also and in winter also, because your crops is utilizing. Winter in most parts of India, the rainfall is not so much, and therefore it's majorly dependent on irrigation, which means groundwater extraction. Okay, and so most of the time in most places the amount of groundwater extracted is much more than recharge rate. Yeah, so recharge happens many a times because of the rainfall, and then to a certain extent, especially in the river basins or nearby, then because of the rivers and underground water can be recharged through the base flow. So that is a different thing altogether. But however, this then has had a huge impact on the land resources, and when the land resources are already under stress, then any climatic changes, any changes in temperature, any changes in rainfall is going to have huge impact. It's just like human body, if we are not feeling well, if you are having some underlying health conditions, yeah, you're not so well, and then you go out in the heat in the afternoon when it's very hot, what happens? You will get affected. As compared to if you're strong, if you're 100% fine, perfect, and you go out in the sun, you might not have any issues. But if you're not well, so when you are already, your body is already stressed, any changes can have huge impacts. And this is one of the huge factor that makes Indian agriculture very, very vulnerable to climatic changes. Any changes in the climatic conditions can have huge impact. And not just for India, but across the world, actually, all of these and climatic changes, and not just that, air quality and various other factor, environmental changes itself is having huge impacts on food production, because of which we are actually seeing a decline now. In the past we see an increase in the crop, but now we are seeing a decline. So here, this is for rice and wheat, and this is how yield have changed between 1995 to 2005. Yeah, as relative to 2000. So you can see here, red means negative. Okay, so across large parts of India, even zero, yellow, dark yellow is negative. So across large parts of India, what we are seeing is yellow, dark yellow and red, which means that post 1990s, you see, from 1960s, mid 60s, we had green revolution, and we see a huge increase in the yield mainly because of intensification. However, post 1990s, what we are seeing is stagnating of the yield. In fact, in some places, the yield is declining because the land resource has been degraded to a large extent. Yeah, so we are already seeing. And on top of that, what we see is we are seeing climatic changes. For example, rainfall. Huh? So this is, I've taken from a research paper, and here they have looked at, for different states in India, the trend in the rainfall between 1901 to 2010. Yeah, and this is monsoon rainfall. Remember, about 75% of the annual rainfall happens during the monsoon season in most parts of India. Yeah, so monsoon rainfall is very important, and monsoon rainfall is important for agricultural production as well, especially the monsoon crops, kharif crops. So here, red means decreasing, green means increasing. 99%, this is confidence level. This is not percentage increase or decrease, but the 90, 95, 99 is showing statistical confidence level. So you can ignore that for now. But from our point of view, what I want to show is, if it's red color, means we have seen during this time a decreasing rainfall. And if it's green, means we are seeing an increasing rainfall. So you see, over most parts of India, we are seeing an increasing rainfall, yeah, in this case. But the problem is that what we are seeing is, this is for the whole monsoon, but during the full monsoon period also, some days it rains very heavily, some days it's medium rainfall, and some days there's no rain or very light rainfall. Okay, so if we break down this monsoon season into different rainfall intensities, then what we see is these are very heavy rainfall. This is the same which I showed you, but this is like very light, no, so not heavy. This is very light rainfall, light to moderate. Now, light to moderate rainfall is very important, because most of the rain percolates into the soil and it recharges the groundwater. But when it rains very heavily, there is a huge runoff which leads to floods. Now, if you look at this, heavy rainfall, very heavy and extremely heavy rainfall, it is green, which means there is statistically significant increase in the rainfall, yeah, during the monsoon season. And this can have huge implications for crops that are grown across India. Yes, because heavy rainfall, which will lead to runoff, and then we are seeing increase in the duration of no rainfall duration. Yeah, there are extended periods where there's no rainfall. So we see across the world, we see changes in the rainfall. This is showing changes in the rainfall and temperature and other climatic conditions, because of which it's already having impact on the yield, agricultural yield. And in future, it says that it's going to have even more impacts in the future. So you see here, the red one, this is future. So between 2010 and 2050, how agricultural yields will change. Yeah, so red means negative. You can see here, white is 0, and this is positive. So in most parts of the world, especially in the developing countries where food security is also a huge issue, here we see negative trends. Okay, so India, again, you can see here, and it shows that, as per statistics, during in India, during 2016 to 2021, it says that about 36 million hectares of agricultural area were affected due to hydrometeorological conditions like heavy rainfall and floods. Okay, so this is the breakup of that statistics you can see here. But every year, large amount of agricultural land area is affected because of heavy rainfall. And this is the same thing even in temperature as well. It shows that temperature, in many parts of India, temperature is increasing. Let me I'm not showing the data here because of I mean, we cannot focus on too many things, but even temperature also, it shows in most parts of India, there is increase in temperature, and this temperature increase is going to have huge implications on crop productivity. Okay, now it is not just that. Along with the changes in climate, the conditions, the increase in the greenhouse gases itself will have an impact on crop production. Okay, now can anyone name a common greenhouse gas? Since you've already had a session last time also, and which is many of us are familiar. So can anyone? CO2. CO2, absolutely. Now, do you think CO2 is good for plants, crops, or no?
Yes, they are good.
In what way?
Because they are important for photosynthesis.
Absolutely spot on. That's very, very important, right? Photosynthesis. So, you know, if CO2 is high, if CO2 increases, then one would say, okay, it's good. Yeah, because it's good for photosynthesis. So it is not toxic in a way, lower level of CO2. But the problem is too much of everything is also not good. Yeah, so when you have too much, vitamins are good for human body, but then too much is also not good. So there is a threshold value above which it is not good. So let us not go into the plant physiology aspects, but then when the CO2 concentration at lower concentrations, it's good. And with little bit of increase in the CO2 concentration, it's absolutely going to be great for crops. So in certain areas, like in the higher latitudes, you know, in northern hemisphere, higher latitudes, CO2 concentration is a little bit less than as compared to in the tropics and equatorial region. And therefore, in those areas, even higher altitudes, little bit of increase in the CO2 concentration may give benefits to plants and to crops, and they may perform better. But after a certain threshold, then plant response would not be there, would not be in a positive way, but it will it will have more negative impacts. And that's one of the reasons why you are seeing green things over here. Okay, it's not only because of CO2, but it's also because of temperature, because these regions are very cold, and therefore, you know, increased temperature would also means longer warm period. And therefore, they can, you know, that during the warm season only crop growth can take place. So they have longer period when they can grow crops, and everything is absolutely fine. Yeah, and so you see that, but in these areas it's not. So CO2 is one. So but CO2 is a greenhouse gas. Yeah, but there's another one, another greenhouse gas, which is ozone. And ozone is also an air pollutant, by the way. So this is very, ozone you see in the stratosphere, and you see ozone in the troposphere as well. Stratosphere is very high up. It is very good for us. You know, you must have heard about ozone from ozone hole and other things, because it protects us from harmful radiation. However, if ozone is in the ground level, on the surface in the troposphere, then it is considered as an air pollutant, and it is also a greenhouse gas. Okay, and so you know, ozone also has huge impacts. This is the ozone concentration, and we see over Indian region very high ozone concentration. And this is showing yield loss, how crop yield loss, this is in terms of wheat, can happen. So the darker it is, the more yield loss it is. So greenhouse gases can also have increase in the greenhouse gases themselves, also can directly impact crops. Not only greenhouse gases having an impact on climatic conditions like increasing temperature and changing rainfall, that leading to impact on crops, but there can also be a direct impact on crops. And the problem, the reason why, what makes agriculture in India vulnerable is, you know, we have a large number of land holdings. Land holdings means individual, you know, agricultural areas, which are small scale and marginal. Okay, so you can see here number of land holding by size, and this is you know, below 0.5 hectares, and this is you know, 0.5, and so you can see here, you know, small land holdings are you know, small land holdings are much larger in number, and most of these marginal and small scale farmers are rain fed. they are highly, and if they're rain fed means they're highly climate sensitive, because if you irrigate your crops, if there is a delay in the rainfall, you can irrigate your crops. But if you are a rain fed farmer and you are dependent only on rainfall, then even a slight delay would have huge implications. Yeah, and we also have very high percentage of population dependent on agriculture and allied sector for the livelihood. So that makes it very, very important. So there are various key risks. For agriculture, we require good climatic conditions. For agriculture, we need to have sufficient surface water or groundwater, right? That's very, very important. And then we need to have good biodiversity, not only the farm above ground biodiversity, but even the below ground biodiversity that will enhance or that will maintain the soil fertility. Yeah, a good soil fertility is also very, very important. However, we have a number of issues. We have, salinity and nutrient loss. We have contamination of the soil. The soil microbial diversity is declining in many agricultural lands because of use of several years of use of synthetic chemicals in the form of pesticides and fertilizers. Then we are seeing depletion of groundwater as well as pollution of groundwater. Then from climate point of view, we have various erratic rainfall, drought, heat waves, cold waves, floods, all of these having a huge impact on agriculture. So agriculture is not only impacted because of climatic conditions, but there are various other environmental conditions that also synergistically with climate have an impact on agricultural yield. And these are all biophysical factors. We are not bringing in only the socio-economic factors. If we bring in the socio-economic and other factors, we see policy and regulation having impacts on agriculture. We've seen in the past many decades, we've seen various policies, that has provided a very conducive environment for growing, rice and wheat, for example, and that has had a huge impact on the adoption of these crops or replacement of other crops by these crops. Then market and infrastructure also has huge issues. Environmental issues like air pollution, pests and diseases impacts agriculture, and there are other things like lifestyle changes and population demand. All of these also impacts agriculture. Of course, it's not that grim, and there are always solutions that are there. Yeah, there are many farm technologies that are been developed to improve all these biophysical conditions as well as protect climate from protect crops from climate stress and so forth. So these are various things that are there from availability point of view. Now, if you look at the accessibility point of view, food access, economic and physical access to food, there are various ways in which agriculture and food can be impacted. See, that we've seen a rise in demand for food. That's what we are seeing, and many research papers are saying that this rise in demand for food, one of the key factors is the growing middle class and rising consumerism. Yeah, and this has led to demand for products such as proteins, fruits, dairy, packaged goods, and high-end products. The consequences, we see more land degradation, and then all of these can also disrupt transportation and lead to reduced accessibility, reduced supply of food, and volatility. Another problem is we are seeing a lot of food wastage. Huge amount of food is wastage. So production itself is a huge issue. It's a challenge under changing climatic conditions. But whatever is produced, a large amount is also, also cause waste. And that also has huge implications on climate as well as on environmental conditions. So one way of a very simple example of climate change impacting food accessibility is tomato and other crops. Yesterday, this screenshot I've taken from yesterday only. I had just put on Google tomato price volatility due to floods, and you see various news articles that talks about how tomato price skyrocket because and that is not only in south, but in north, east, west, where because of heavy rainfall or floods or landslides. Yeah, so we see that we experience it not only in tomato but various crop. Now what happens is that when food prices change, when there is a food price hike, the households in the lower pyramid actually are affected the most, because then they'll have to compromise because on various other aspects. So this is a huge problem. Then there is the food wastage. Okay, large amount of food goes waste. And this food wastage is not only a problem of developing countries or emerging economies, but it is also for developed countries and industrialized countries as well. So you can see here Europe, industrialized Asia, Oceania, these are all high income countries, but even the wastage is high. Many a times their wastage is not because of absence of technology, but because of strict norms, food safety norms, because of which, like best before dates and all of these, because of which it leads to wastage of a large amount of food that is produced. But if you look at South and Southeast Asia, maximum food is wasted at production and retailing. Okay, so this is dark brown is consumer production, because of and along the food value chain. Why? Because we have also storages, absence of storages or less access to storages also can lead to large amount of food that goes waste. Yeah, inefficient market mechanisms, all of these can have huge issues and can lead to huge amount of food that is wasted. But in terms of the food that is wasted, large amount of food, it ends up in the landfill. And from the landfill, then, these become source of huge amount of greenhouse gases, especially CO2 and methane. So a large amount. Its statistics shows that globally 6% of greenhouse gas emissions come from food losses and waste. So that's a huge amount. So you see, with increase in temperature, with increase in humidity, because of climate change, these are all part of climate change. Actually, it's not because of climate change, but increase in temperature, so these are all the aspects of climate change, and this can lead to requirement for more better food processing and better storages, because the shelf life of the food decreases, you see, and that can lead to increased food wastage. But the food that is wasted ends up in the landfill, and they can lead to increased greenhouse gas emission. So we are seeing a feedback mechanism. We see increased greenhouse emission leading to changes in the climatic conditions, that leading to increased wastage, and that then again back to square one. And as we close the loop, we are seeing that emission has increased further. It's like a spiraling loop, which is not the best thing. And then we see, so let's look at food utilization. We see malnutrition. And when we talk about hunger, malnutrition, when we talk about malnutrition, when we think about this, many a times we think about hunger, people who are not having sufficient food to eat on insufficient. But malnutrition is not only undernourishment, but also overnourishment. So we see we see a large number of people, hungry people, undernourished people in South Asia. Okay, the numbers here are in terms of percentage. The bar graph is percentage. That's why in sub-Saharan Africa, hungry people as a percentage of the total population is high. But in terms of absolute number, South Asia is much more. So this is in terms of hungry people. However, overnourished, and the outcomes of these are overweight and obesities and so forth. So we see overweight and obesity very high in high income countries. But in Asia and across the world, we are seeing that the number of overnourished people are increasing. And it's the other side of the coin. This is a huge problem. We see this as an emerging issue. So when we talk about food insecurity, we also have to look at this undernourishment and overnourishment. Even in India and all, cities are actually, we have huge issues of overnourishment. Yeah, which is another form of malnutrition. And this leads to huge problems, different types of lifestyle related diseases that are there. Okay, so we have expansion of food availability. Huge type of food is available like this. So we see an emergence of supermarkets, and as supermarkets increases, we are seeing food brought from worldwide across the world, and that means more carbon footprint, first of all. Now, second is you have to bring food from different parts of the world, different area, you have to ensure that the packaging is good. Otherwise, the food will go waste, and therefore more packaging. More packaging means more carbon footprint, more environmental impact as well. So as we move from local kirana shops to more supermarket driven, market, then we have issues. Even fresh vegetables which are not processed, we are seeing a change from this type of market to the ones on the right. So all of these have huge implications. And it's not just that, we are also seeing an increase in eating out habit, eating away from home. I'm not saying it's bad, but what I'm saying is that there is an increasing trend. I just took a map here. This is a map of our university in Vasant Kunj. And, I just Googled eating out joints, and we see a huge number of eating out joints. All of them are not visible because, this is a mall. There are 3 malls over here. So there are a large number of food joints in this place, very high density. But across India, especially in urban areas, we are seeing a rise in the eating out away from home. That's what we call. And all of these also increases food wastages. All of these also lead to increase in carbon footprint, and that may lead to huge implications on human health. So the question is, what can be done? What can be done? And especially because in future food demand is going to increase, and so in future we will have to produce more. But as we try to produce more, we are also under continuous stress from natural resources like water and soil resources and land resources, as well as also climatic conditions, various climatic changes that can have huge implications. So there are various things that can be done. So one example is from a research that we've done. Quickly, I'll show that, where it's a simple solution. Okay, in the mountain, we did a research in Nepal, in Kathmandu, with one of our students from Nepal. And so in mountains, actually, mostly they're vegetable farmers, and they have to go downhill to the market because usually markets are in the valleys. So they have to carry huge load many a times because transportation is also not very great. So what they are doing is, in many places, this is in Kathmandu Valley, but in the hills around surrounding Kathmandu Valley. So they are using gravity good ropeways. Okay, so so this is mainly, it's not operated mainly based on gravity. You have 2 baskets. One basket you put load from uphill, and then niche you put other goods like market goods, and then so as it comes down, this lifts up. So this is what they are using uphill. So this gravity good ropeways the farmers have started using for transporting their fruits and vegetables which they grow, and so it saves a lot of time, because they have to, travel 2-3 hours to reach the market base here. So using this, it requires only few minutes. So this is what farmers are doing. This is at the base of that gravity good rope base, where there are few farmers who sits here to collect, and then they sell it. So what we found was that, and this is very climate friendly in a way, because it doesn't require electricity. It is purely on gravity, and therefore it is also not very expensive. It's cheap. So these things like this can be solutions. What we found was, like, the transport time is reduced. Farmers are able to reach market and sell vegetables when they're still fresh. And therefore, it also reduces post-harvest losses. It increases their income. It reduces their transportation cost and various other things. So all of these can have impact on reduced emissions in terms of climatic-related benefits, improve livelihood of farmers because they don't have to come down all the way to sell it. It reduces food wastage. It improves farmer health because with increase in the income, they're able to invest in better food and so forth, and improves food security. And when we look at so these type of solutions, I'm just showing a few solutions, just one example, but all of these can really help in transitioning towards a much healthier and safer, diet, which are also sustainable environmentally, and it can help towards making the agriculture and food system much more resilient to future climatic changes. Yeah, and actually, if you look at sustainable food, sustainable and climate friendly food can actually be healthier and cheaper. So if you go to the vegetable market, if you eat seasonal, if you eat or if you buy seasonal and local food, seasonal food means you don't have to put in much effort, so it's more climate friendly. If it's local means there's less carbon footprint. The crops have not traveled that much, so there's less carbon footprint, so it's, in a way, you can call it as climate friendly. But actually they are more cheaper, huh? If you go to the vegetable market, at least in Indian context, if you go to a vegetable market and you try to buy local and seasonal food, they are much cheaper, and they are more nutritionally also they are better. So of course it's not always the case, but it's not necessary that climate and sustainable and climate friendly can be more expensive, because people talk about health food, organic food, which are very expensive also. But we can actually be very we can look at it from this point of view, and then this can be a lot more even healthier and cheaper as well. So I think let me stop here because I can see the time, and I'll open time for questions.
Yeah, thank you, ma'am. So if there are any doubts, you want to interact with ma'am, please feel free to interact with ma'am. Participants, in case of any queries.
Good morning,
Good morning, ma'am.
First of all, thank you for sharing valuable knowledge, ma'am. My
you.
question is, like you have spoken about green revolution. We
Yes.
know we have used chemical fertilizers in large amount and still we are using them. But yesterday, ma'am, sir also said that food is becoming poisonous due to these kind of activities. So, ma'am, how can we increase yield without using them?
See, the problem is, see, it's not chemical as such. Chemical can be natural also, but here we are talking about synthetic. Okay, synthetic ones, which are fertilizers and pesticides, which can be harmful. It may protect the crops, it may help the crops produce more, but it might be harmful for our health. There are many ways, like in which people are now trying to grow, and it takes time. Like organic farming is one of them, but organic farming, if you were to convert some of the farms in let's say Punjab and Haryana, which are highly conventional for many years, they've been practicing, to convert that into fully organic will take a lot of effort and many years. So I don't know about it. I don't know how long it will take, but in certain places people are converting, like Sikkim has tried its best to make it 100% organic. So organic is one way, and there are research papers that shows that yield initially declines, but later on, as you progress, as you continue with organic farming, your soil quality improves, biodiversity improves, so the yield also increases. Now, one very commonly used, criticized also, but commonly used farming technology is zero budget natural farming. Yeah. So in Andhra Pradesh, for example, people are promoting this zero budget natural farming. So there are many other sustainable forms that can help in getting good yield without actually using these harmful synthetic pesticides and fertilizers. So there are ways of managing that.
Okay, ma'am. Thank you so much.
Welcome.
Yeah, hi, Ms. Kami.
Hello. Yes. Hi.
Um, well, I have two questions. First is regarding it has a connection with what you recently answered. But if you are aware that what we are seeing in Sri Lanka, that they are facing a very bad kind of food shortage. I was reading yesterday about it. Like the milk prices are going higher and higher, and other important commodities. So I would like to know. Well, when I asked one of my Sri Lankan friends about the reason, and I also read that they totally shifted their agriculture to organic farming. So is it correct that if we also start or giving option of organic farming to our farmers without doing any groundwork level work to know whether is it sustainable or not? Sustainable in the sense whether it can give us the benefits.
Yeah.
And the second question, which I would like to know, do you have any idea or any study regarding the effect of methane, which is also a greenhouse gas, as you mentioned, ozone and CO2, like how it is affecting agriculture? It is just a question which I'm trying to know the answer from you.
Yeah,
Thank you.
thank you very much, Mr. Deepak. Organic is one sustainable form, but it's not necessary that it will be sustainable everywhere. You know, this word sustainability is very context specific. You see, so in a state like Sikkim, you know, most of it's a hilly area, and most of the farms were still, you know, people were not using these synthetic chemicals, so it was easier for them to shift. But if you were to ask a farmer in Punjab or Haryana to shift to organic, I mean, it's going to take a huge whole many years and a huge effort to actually bring the farm to that condition. Secondly, it is very, that's why I said it's important for us to look at a look at it as a system, you know, in that involves everywhere. So you have to do the groundwork before you would suggest anything. You have to train the stakeholders, including the farmers and even the market people. You see, in many parts, not only in India but many parts of the world, farmers get a lot of support on how to grow cash crops, okay, and they do well, and you know, some farmers will initially adopt that, and then they'll grow a lot, yield is fantastic, they get a lot of income. Following years, many farmers follow the example, and you have a lot of farmers that produces some crop in huge quantities, and then there's no market to sell it, and then everything just, you know, topples down, and that becomes a problem. And therefore we have to take a very systemic approach in that, in this context. Now the second question was, I forgot. Can you repeat that?
About methane.
Methane, yeah, methane. See, methane in terms of agriculture emission, lots of papers are there, but I've not come across a paper that talks about negative impacts of methane on agriculture. Direct ones, of course, via climate change, that's a different thing, but direct ones, I'm not aware of it, so I will not be able to comment on that.
No problem. Thank you very much.
Good morning, ma'am.
Yes, hello, Rhythm.
I have a question. Nowadays, that we are emphasizing on more on hybridization of crops such as BT cotton, BT brinjal, etc. So many feel that we are making the evolution faster. So that can impact the climate, or if it is the case, then what are the alternatives we can take?
Yeah, it can hybridization is different from GMOs. Okay, genetically modified is very different. Hybridization is something which farmers have been practicing for many generations, I suppose, even from the time agriculture evolved. So it's a very natural form of hybridization. Now GMO, there are pros and cons about it. You know, we still don't know what will be the outcome. But then given the resource constraints, given the extreme climatic conditions, there are many scientists that also argue that GMOs can be a good solution in addressing the world food crisis if the situation gets worsened, and the question is about producing sufficient amount to meet the need versus sustaining the environment and other risks that are there. So there are pros and cons regarding GMOs, but more, of course, in terms of the concerns, because we still don't know what will be the exact impact later on.
Okay, ma'am.
Hello, ma'am.
Okay. Any other?
Hello,
okay, yeah, there is one.
I think we are 5 minutes late. Sorry about that.
Hello, ma'am. Am I audible?
Yes.
Okay. So first of all, thank you, ma'am, for your very much valuable information about everything. And actually, ma'am, my question is, you talked about contaminated food. So we know that due to increasing demand, farmers are focusing on increasing the intensity of the land. So they are using pesticides, and automatically, either knowing or unknowingly, we are consuming that contaminated food. So I mean, whether he or she is educated or not, they are taking that food. So what is the solution for that, to be aware of that this is contaminated food or not?
Whether it's contaminated or not, I mean, if it's highly contaminated, we can kind of make it by smell or not, but other than that, even I have no idea how we can figure out whether it's contaminated or not until and unless we do maybe some tests or some experts. So I don't think I'll be in a position to say that. definitely. But then one solution is, with farmers also, we can always see, we don't have to tell them to become organic. Becoming certified organic is a very different thing altogether, but we can actually help and train the farmers to use the pesticides in a moderate way, in a judicious way, not just applying it. And many a times the problem arises because they're using it, whether it's irrigation or using fertilizers or pesticides, they're using it in a very unsustainable way. No? So just putting the right amount at the right time would help. And then so that's the only solution.
Yeah, sorry to interrupt, but our next speaker,
Yes.
Dr. YB Singh, will be talking about the organic. He is the certified. And that time this question will be the answer by our next speaker. Okay. So because there is no question, so we are moving towards the next. So invite Dr. Sunita Yadav again to the thanks to the one speaker and be introduced to the next speaker. Over to you, ma'am.
Thank you, sir. Thank you so much. So it is my honor and privilege to extend a heartfelt thanks to Dr. Zamir. Your talk was, ma'am, in a very subtle way. You have explained a very important, concept of food security, and it is a need of the hour. And you have explained all the dimensions of agriculture, the 4 dimensions of food security. You have explained very well, and I know these students, the participants, they have a lot of doubts or queries. So I hope you will be, available to us through mail or through something, so that in any case, if the students or the participants, they have any doubts or queries in future, or they want to contact you, so they will be, able to contact you. So thank you so much, ma'am, for sparing the time and for being a part of our online course. Thanks a lot.
Thank you.
Yeah, thank you so much, ma'am. And student and the participants, as you are one of the person is asked to the Professor K.S. Rao in the beginning, where you can pursue for the MSc in the climate change. So I am saying that the Terry School of the Advanced Studies is also given to the MSc in the climate change. So this is the things, and Dr. Chuba is the coordinator of that program. Okay.
Okay, so now it is my privilege to introduce Dr. YP Singh. So we welcome you, sir. Good morning. Dr. YP Singh was the ex-director, ICAR, Central Soil Salinity Research Institute, Lucknow. He has been honored with ICAR prestigious Hari Om Ashram Trust Award 2010-12 and also the ICAR CSSRI Excellence Award for outstanding contribution in the field of salinity management. Sir has more than 34 years of research, extension and management experience in the field of natural resource management. And out of this, he has more than 23 years of post-PhD research experience in the field of agronomic research, training and extension on rice-based farming system in salt-affected soils of Eastern India. He has conducted various multidisciplinary field, national and international research projects. And on the basis of his projects and his work, he was also appointed as a consultant crop production in the International Rice Research Institute, IRRI, ISRO, Tanzania. And he has worked as a consultant there in the East and Southern African Regional Office, where he established collaboration with the NARS partners through various joint meetings, project planning, conducting collaborative field trials and demonstrations on location-specific nutrient and water management for rain-fed lowland ecosystem. Sir has more than 100 research papers in peer-reviewed national and international journals, 5 books, numerous book chapters, and various research papers to his credit. He was also associated in developing 8 rice varieties, 1 wheat variety, and 2 mustard varieties for salt stress conditions. Sir has also developed a gyp kit for estimation of gypsum requirement at farmer's doorstep and also an app, a mobile app, GypCal, a user-friendly mobile app for calculating the gypsum requirement. So sir has been, in direct collaboration with the farmers, and he has, developed various such, like he has also developed a liquid bioformulation, HaloAzo, HaloPSB, which comprises of the halophilic strain of the nitrogen fixing and growth promoting and phosphate solubilizing bacteria. And the list goes on. Sir, we welcome you, and we are glad that you are a part of this online course in environment, diversity and climate change. We welcome you, sir, and the virtual dice is all yours, sir. Thank you.
Sir, you can mute. You are muted. You can unmute first.
Sir, please, sir, unmute yourself.
Yeah, so thank you very much, but please help me to share the screen. Most of the time I presented on Zoom, so it was easy to share the screen on Zoom, but on Microsoft so I'm trying my level best to share this screen, but not able to share.
Sir, you can just click the upward arrow key.
Yeah, I click that, and there is a screen share, the desktop or window.
Yeah.
So then I click the screen and window, and there is a choose what to share. Entire screen, window, Chrome tab. What should I click?
Screen.
Entire screen.
Yes, sir.
Okay, sir. Nothing is there.
You can share the entire screen.
Yeah, I click the entire screen, but it is not.
Okay.
No.
Yeah. Coming, sir. Something coming. Wait.
It is coming?
Yes, sir. Now you can open your PowerPoint screen. Yeah, it is coming. Yes, sir. Now you can go to this.
Is it okay?
Yes, sir. Okay. You can go to the slideshow mode.
Slideshow mode. Okay, sir. Yeah, is it okay?
Yes, sir. It is perfect.
So.
And if possible, you can hide this hide button.
Pardon?
It will be the stop closing and the hide.
Hide.
Yeah.
Click. I have to click hide.
Yes, sir. Okay.
Is it okay?
Now, yes, sir. Now come to the first slide. We are
Yes, sir. Yes, sir.
Yeah.
So can you hear me?
Yes, sir. Now it is perfectly perfect, sir.
Okay. Thank you. Thank you, Doctor. Thank you very much.
Okay.
So I am highly thankful to Dr. Abhishek sir for inviting me to deliver a lecture. We met in Babasaheb Bhimrao Ambedkar Institute, University long back, and he was recollecting me and invited to deliver a lecture. So I'm thankful again. Once again, I thanks to Dr. Abhishek ji. Madam has given good introduction about my work and about me. So my topic is most of my work since last 10 years, although I have worked on many aspects in the field of reclamation and management of salt affected soil, but since last 10 years I was working mainly on this solid waste management, and it was the first study in the country that till today that no one has done the work on management of solid waste for reclamation of salt affected soil. You know very well that reclamation of salt affected soil through chemical amelioration is a very costly affair. Earlier it was cheaper when gypsum was easily available to the farmers, and there was no restriction on mining of gypsum, because gypsum is the only chemical ameliorant for the reclamation of salt affected soil. But nowadays, because of the environmentalists, they are creating problem to mining of gypsum. So we have to find out the alternative. What alternative should be for the management of for the reclamation and management of salt affected soil. So we think that we are having a large quantity of solid waste solid waste, which is available in the abundant quantity in the metro cities. So how best we can utilize that for the management of salt affected soil, or in addition to that we can utilize that for our environmental protection, for our human health protection. So how best we can utilize. So I worked that. So I will share my work. Most of work, whatever I did in last 10 years. I was having the one UPCST project, and one project was UP Council of Agriculture Research project. So in both the projects, I have done a lot of work on management of salt affected soil and with the utilization of solid waste. So now please. So next, the question is what is municipal solid waste? So there are different views of different scientists working in different fields. So some engineers define that municipal solid waste as material that are discarded from the residential and commercial sources. That even we people, normal people, common people think that whatever we discarded from our house or of our locality or our surroundings, that is our waste, or we can say municipal solid waste, or the material that have ceased to have value to the holders. But the anthropologist point of view, that the garbage is factual evidence of a culture, that what people have owned and thrown away can speak more eloquently, informatively, and truthfully about the lives they lead than they themselves ever may. So these are the different opinion of engineers and anthropologists, what they think about the municipal solid waste. So there are certain challenge. This is a very, nowadays it is a very big burning issue. That if you go to Delhi or in big cities, you find a big heap of this solid waste. And because of that, the environment, our environment is polluting, our soil is polluting, our water is polluting. So there are many more problems. Our human, the people which are living around those dumping yards, dumping stations of this solid waste, they are facing a big problem of diseases, and even our crops are affecting because of these dumping yards, or you can say the place where this municipal solid waste is dumping. So there are certain challenges that the post-consumer waste through its production and management affects air quality. It is affecting air quality, water quality, public health, and it contributes to climate change also. The earlier speaker has very widely elaborated on the climate change, and I respect him. He was a very good climatologist, and he has collected a very good information. I was really impressed with this lecture he delivered. So the improperly managed waste can affect the environment. It is affecting environment at different scales. Open dumping of waste contaminate nearby water bodies with organic and inorganic pollutants. It also threatens public health by attracting disease vectors and exposing people living near the waste to the harmful products within. And the incineration of waste emits a variety of pollutants. You can understand very well. They emit the very different kind of pollutants, including dioxins and furans, persistent organic pollutant that mix globally and harm human and ecological health. So these are the certain challenges which we are facing with this municipal solid waste, which is dumping or which is collected or storage at dumping stations. So this is what is the impact of this solid waste on our environment. So the emission of pollutant from solid waste, this is the major effect on our environment. So these are the certain pollutants emitted from various waste technologies. Though you say that in air, what is the environment? Air, soil, and water. What are the dumping stations? These are the polluted emitted. The carbon dioxide, CH4, or odor, noise, and these are greenhouse gases. And certain type of the gases, these are emitting from the dumping stations. And where is this composting? Where we are making the composting of these solid waste, their greenhouse gas and bad odor you can find there. And when we are applying that land application in that soil, then bioaerosol odors and greenhouse gas is also emitting from these solid waste. And then similarly, like when we are recycling it, then again the greenhouse gas is emitting from these. And when we are transporting this transporting from the city to the dumping station or treatment plant, and then carbon dioxide, sulfur dioxide, and then nitrous oxide and other things are polluting the air. Similarly, in heavy metal, when we are applying this in soils, so there are the problem of heavy metals and organic compounds. When we are composting, utilizing the composting in soil, then there is minor impact. And in bacterial, virus, heavy metals, these are the certain. So this type of, because of this solid waste compost, these are the certain effects on this our air, soil, and water. Even on water, if you see water, that heavy metal organic compounds, when through the leachate of the solid waste, our water is polluting. So these are the certain impact on our environment in air, soil, and water. And then waste management on public health. What is the effect? What is its effect on public health? The lack of proper waste management leads to waste accumulation, which attract diseases, vectors, can clog drains. And you will find that in cities, most of the drains are full of, are choked with the plastic and many more things, and they create habitats of mosquitoes and infectious disease to our human beings or public, affect the public health. And then if we are open burning of waste emits a number of toxic substances which directly harm people. And then living and working near landfills, those who are residing near the landfills have been associated with congenital birth defects. It has been reported that they have the congenital birth defects. The proximity to incineration is linked with cancer incidence. It has also been reported in certain literature that because of those people residing near the dumping yard, dumping stations, and they have the cancer incidence. And breathing air near composting facilities is correlated to respiratory illness. So these are the certain problems because of the poor management of, we can say, because of the poor management of this solid waste. And now, what is its effect on our ecological health? It also affects our ecology. The emission of toxic chemicals have acute impact on harming flora and fauna. And then most of the hazardous of these waste, hospital waste, industrial hazardous waste can be released directly to the environment if dumped or burned openly. So there are in big cities, this is very harmful, that the hospital electronics goods, hospital waste is more harmful as compared to the house waste, or you can say the or industrial hazardous waste. They are very harmful, and they are part of also our solid waste. And then municipal solid waste directly affect the health of oceans. If you see the oceans, in our oceans, that at least 267 species ingest or are endangered by plastic, leading to increased morbidity and mortality. If you see, if you go to the our ocean, our beaches, you will find a large number of plastic, large quantity of plastic coming out of that sea. So that is because of that our certain species, fish species, or certain other species are affecting because of this solid waste, which is poor management of this waste. And because of the plastic absorb persistent organic pollutants, they concentrate toxins and become vectors of poisons that accumulate through the food chain. And sometimes what happens when we are using that, observe that affect our food chain also. Sometimes some heavy metals or some pollutants are we noticed in our food products also, because of this utilization of this throwing or improper use of this solid waste management. Now, if you see the status of solid waste in our country, about 90 million ton of solid waste is generated annually and dumped in dump yards. This is in our country. The disposed of is open ground dumping or non-sanitary landfill. These landfill sites are an environmental hazards. They are I have already told you in our earlier slides. Given the current development, the generation of municipal solid waste in India in the year 2047, it has been projected that it will be 260 million tons, a number of more than 5 times the present level. It is increasing in a very, very faster rate. The amount of municipal solid waste generated per capita in India, its average per capita generation is about 0.5 kg per day, or it may be increased to increase at the rate of 1 to 1.33% annually. So you can imagine that what will be the situation in near future. If you see the per capita generation rate in Indian cities, in different cities, Indian cities, so if you see the Ahmedabad to Varanasi, if you see the 5.8 and the Ahmedabad is 0.58 kg per day, it is generated per family. We can say generation rate per kg per capita per day. So the maximum is in Madras, and if you see the Lucknow, it is 0.62. It is very high rate of this solid waste production in Lucknow. And if you see in Madras, it is 6.657. So like that, it is increasing as per the you can say the category of city, or you can say the standard of living is also playing an important role in the generation of solid waste compost, because the people which are you can say which are rich in they produce more solid waste as compared to the poor peoples. So this is the status of Indian cities of solid waste. And now come to the UP, because I have studied in UP, so I will focus on emphasize on UP also. So according to CPCB report, Uttar Pradesh is producing about 5515 ton of municipal solid waste per day. The magnitude of the problem is likely to grow even larger unless immediate steps are not taken. So this is the problem in Uttar Pradesh also. Solid waste management is the major challenge, not in UP. This is the major challenge for researchers or our policymakers to manage this burning problem. How we can manage this problem, or how we can tackle this problem. So now come to the Lucknow. I studied in Lucknow, so I have generated lot of data from Lucknow city. The Lucknow city produces about 1,500 metric tons of solid waste per day, but the municipal solid waste treatment plant which established in Lucknow is having only capacity of 200 to 400 metric tons waste management per day. But production is 1,500 metric ton, and management capacity of our treatment plant is only 200 to 400 metric tons. The management of municipal solid waste in Lucknow is not sound structured. Another problem is it is not sound structured, and the reason behind is it lack of awareness among the citizens, as well as the inaction of the civic bodies responsible for handling and management of the municipal solid waste. The waste processing and disposal mechanism in Lucknow is as majority unscientific, and we can say it is unscientific and involve mainly open dumping. In most of the places in Lucknow city, if you see it is dumped in open places. Even there is no covered space to protect from its effect on our human being or our environment or like that. So it is like, if you see the category wise, the income wise, the generation, then you see the low income group is approximately per capita generation is 192 grams per day, and the waste generation percent of this percent is 27% is waste. Approximately per capita waste generation gram per day, it is 27% is total of generated by the lower income group, and 32% by the middle income group, and 40% by the higher income group. Or you can say, as the income level is increasing, the per capita generation is also increasing. So there are no measure of landfill gas capture. You say the unscientific ways they are managing this problem, but no measure for landfill gas capture or destructions. The open disposal lead to uncontrolled anaerobic decomposition, and because of this, the problems. What problems are? I have already told you that release of methane into the atmosphere. This methane gas is releasing in the atmosphere, which is one of the prominent greenhouse gas. Also the leachate where it is dumped, the leachate in the landfill seeps into the soil and pollute the groundwater and surface water. Recently, what steps Lucknow has taken, that Lucknow city is divided into 110 wards and 6 zones for solid waste management, and is responsible for collection, treatment, and disposal of municipal solid waste generated in the whole city. And then, if you see the source of waste, kahan se aa raha hai, from where we are getting the solid waste: household 42%, restaurant 28%, street sweeping 6.8%, market 15.8%, and offices 4.2%, hospitals 1.7%, and hotels 1.5%. So this is the source from where this solid waste is generating in Lucknow city. Now, when we surveyed, when we started the work in the project, we surveyed in different colonies of Lucknow city, and then this is the feedback. We collected the developed the questionnaire, and find out that is improperly disposed will cause the following impact on our environment and health. So the people said that groundwater contamination by leachate generated by waste dumps, surface water contamination by the runoff from the waste dump, bad odors, pest, rodent, wind blown litter in and around the waste dump, release of greenhouse gases, and fires within the waste dump. You see, you might have seen that where it is dumped, there most of the time there is fire and the smoke is there all around, because of the high temperature inside, and the gas formation. So it is burning like situation is there. And epidemic through stray dogs, and most of the time you see the stray dogs are in search of food from the dumping stations, dumping yards. So they are also another problem. And acidity in surrounding soil, increase mosquito around the dumping site, affect animal health and diseases. So these are the certain problems, feedback which we got from the farmers. So now the question is what we should do. Now, question is how best we can manage this problem, management of this problem. So management, we initiated the work on the composting for agriculture used. We worked, because of being an agriculture scientist, our agriculture research institute, we took the work on composting of agriculture, and then composting for agriculture purpose. And there are other ways, other utilization of other use of this municipal solid waste are also this treatment plant are producing like that. They are energy production, then biogas and bioenergy in the form of pellets and fuels, and use of infrastructure development. At certain places it is using at filling road. Sometimes at making the road, they are using this is in the filling landfill material also in this solid waste. So there are certain management options, but I'll emphasize on composting of agriculture and how and its utilization for the management of salt affected soil. So this is the same. Sorry, this is again, and then the initiative, the government initiative, the Uttar Pradesh government has initiated integrated municipal solid waste management project, and emphasizing on management of municipal solid waste and its utilization for agriculture production. The government of Uttar Pradesh has established some municipal solid waste treatment plant, but those municipal solid waste plant, they are producing the compost. Treatment plants are converting the compost, but the cost of that compost, and that compost is available in the market, but the cost of that compost is very high. It is about 250 rupees per 5 kg, or you can say 50 rupees per kg, and that is beyond the reach of small farmers. If you see the recommendation of compost in the field, not in salt affected soil, but if you see the normal crops, it is about 15 to 20 tons per hectare. So it is very costly affairs if the farmers buy from the municipal solid waste treatment plant. So it is better to make the compost of this municipal solid waste plant at his own farm, or you can say the on-farm composting of municipal solid waste. We worked on that aspect, and we developed the protocol for how best we can make the on-farm composting at cheaper rate, at cheaper prices at farmers' labor doorstep. So, and with this, we initiated the experiment to standardize the method of on-farm composting of municipal solid waste, and to estimate the rate of decomposition and nutrient mineralization of municipal solid waste, monitor the combined effect of municipal solid waste and inorganic amendments on improvement of soil health, and they find out the efficacy of inorganic amendments used in conjunction with municipal solid waste compost on sustaining crop productivity in sodic soil. So we initiated the work with the following these certain objectives, that how best we can improve the soil health, and how we can utilize this municipal solid waste for composting purpose. So with these objectives, we initiated the work. And for that, what we did, we collected sample from 11 dumping sites of Lucknow city. Now, these are the 11 dumping sites from where we collected the sample of the municipal solid waste, and then we analyzed that physical, chemical, and biological properties of the microbial properties of these collected samples. And if you see the physical composition of Lucknow city municipal solid waste, the decomposable waste is 36% only, and then plastic is 18%, and then bricks, pebbles, and the concrete and soil like that, these are 16%, and metals 9%, and wood 8%, rubber, leather, and textile 8%, and glass 5%. This is the composition of solid waste of Lucknow city. And then if we also collected this compost from other different cities like Kanpur and Varanasi. If you see the difference between Kanpur and Varanasi and Lucknow, in Lucknow, you see that Lucknow, there was decomposable waste was 36%. However, in case of Kanpur, it was 38%, and Varanasi, it was 48%, which can be converted into compost. But the problem in the Kanpur, you'll find that leather, because of leather industry in Kanpur, so the 5% there was 5% leather, but in Varanasi there was no leather in the municipal solid waste, and plastic. But in plastic in Varanasi it was higher as compared to Kanpur and Lucknow. So this is the situation of the physical property composition of that solid waste, and then chemical composition of composting material. So to making the compost. For the on-farm compost, this study was not only for our you can say our research purpose or our academic purpose, but for the farmer's point of view. So whatever the organic waste farmer is available, farmers is having at his own, अपने घर पर, अपने खेत पर, अपने घर से जो निकलता है, अपने घर के सामने जो उसके कोई पेड़ खड़े हैं उनकी पत्तियां इकट्ठा करके, और जो घर में गोबर आ रहा है उसका गोबर को इकट्ठा करके, so at our research farm we were having that the spongamia plantation, and then casuarina leaves we collected, and then mustard straw which we harvested and we utilized for composting, and then paddy straw we utilized. So and this is the municipal solid waste. Whatever the solid waste we collected, and we mixed these agriculture waste also, so that farmers can use that agriculture waste and municipal solid waste, he can put together and make a compost. So this was the composition of, if you see the initial property of municipal solid waste, that CN ratio was very high. It was 54.86, which is the important parameter to determine the quality of the composting material. And if you see the total carbon 28.3%, and the nitrogen was 0.52, phosphorus 0.05, potassium 0.28, calcium 0.36, like that. But if you see the composition of other the agriculture waste, also in agriculture waste, this mustard straw was having a very high CN ratio, and paddy straw 70, followed by paddy straw 73.4, and then casuarina leaves, and then spongamia leaves. So this was the composition of which filling material we used to convert this municipal solid waste into municipal solid waste compost at through on farm. Now if you see come to the agriculture situation in India, the agriculture in our challenges facing our agriculture is facing in India is degrading soil health. Soil health nowadays is a major issue, and so our soil health is deteriorating. The organic carbon content is deteriorating every year because of continuous cropping and certain this continuous use of this chemical and fertilizer and chemical fertilizers and like that. And then imbalanced fertilizer use is another problem India agriculture is facing, and emerging multi-nutrient deficiencies, particularly secondary and micronutrient. Earlier we were applying only farmers, we were recommending to the farmers only NPK, but slowly the demand of this sulfur and then magnesium, other nutrients is also coming up, and deficiencies symptoms are visible on the crops. So this is a multi-nutrient deficiency is nowadays the agriculture is facing. Then decline factor productivity, and then slow growth in food productivity. And our productivity, our crop productivity is now stagnated since last 5 or 10 years. If you see the productivity of rice and wheat major crops, it is not increasing in such a way that which was increasing 10 years back. But this growth is, you can see the production growth trend is stagnated. And then climate change, another agriculture is facing, which the madam our earlier speaker has delivered you about the climate effect of climate change on agriculture very well. And now we come to the soil health, which is major issue. And the soil health, what are the major factors influencing soil health? Is soil moisture, soil temperature, soil pH, soil organic matter, and then nutrient, and then beneficial microorganisms. These are the major factors. These are influencing our soil health. And now how we can manage the soil health management is another important. And then I will come to the use of how best we can utilize this municipal solid waste for managing the soil health. The soil health management, these are the certain issues related to soil health management. Number one is declining level of soil organic matter. And to manage this problem issues, manage organic matter. So we have to add organic matter. And then organic matter, the municipal solid waste can be a good source of organic matter not for only for salt affected soil, but for all crops which compost. If we are able to convert this municipal solid waste into a municipal solid waste compost, then it will be a good source of organic matter to maintain the soil health. And now widening NPK ratio. This NPK ratio is day by day, it is widening. Farmers are not aware of about this ratio, so they are just applying. Most of the farmers are applying nitrogen in a huge amount. If you see the data of Haryana and Punjab, they are applying 200 kg or 250 kg in certain crops, 250 kg nitrogen per hectare. But phosphorus and potash, they are not applying in a equal proportion. So the strategy, what we can do to minimize this, to maintain this gap, minimize disturbances, and conservation tillage. Conservation tillage is another strategy which can maintain this NPK ratio. Conservation tillage means the minimum tillage and residue management. Whatever the residues we are getting from the crop, we should utilize those residues in the soil and decompose those residues so that they can produce NPK in a relative manner, you can say. Then micronutrient deficiency is another issue to manage soil health. And then for that, diversify the soil biota. This is the strategy. With this, we can manage this micronutrient deficiency. Declining response in terms of grains per kg fertilizer, or you can say nutrient use efficiency is declining. Then how to maintain soil cover? With this, if you cover the soil crop of residues, then loss of nutrient can be minimized through evaporation or through volatilization losses of nutrient. There are certain losses of nutrients. So we can, if we cover the crop, or we can say the conservation tillage is important to manage this issue. And then heavy metal pollution is another problem. And for that, with the crop rotation can be a strategy to manage the heavy metal pollution in the soil. And low nutrient efficiency and land degradation. And these are the certain organic amendments can play an important role in managing the soil health. And so what are these different sources of organic amendments? There are many sources of organic amendments, like animal manure, like compost, like crops and crop residues, then municipal waste, organic waste from food processing industries, organic waste from paper mills, timber industries, and brewing facilities, and post-consumer food waste. These are the certain sources of organic amendments or organic to maintain the soil health. And now these are the amendment provide different benefit to the soil. I have already explained, no need. Now come to the salt affected soil. Come to my main area where I have about 36 years of my research field experience. And so most of you are aware that India is about 6.73 million hectare sodic soils, and out of the 6.73 million hectares salt affected soil, and out of that 3.77 million hectares sodic soils, and 2.96 million hectare is about saline soils. So this is, if you see the red spots, and these red spots, these are the sodic soil, or you can say alkaline soils, and these are the blue spots, these are the saline soil. So these are the major areas of salt affected soil in country. So how best we can manage the characteristics? If you see the characteristics of these sodic soil, which are in large area in the country, sodic soil, if you see in the summer season, you see this photograph, during the summer season, there is a white crust of about, you can say about 15 to 20 centimeter thick white crust on the surface. If you pass through that area, your foot will insert. You can see the foot picture. This is the summer picture. When it is after rain, when it is dry, it becomes like that. So these are the physical appearance of this sodic soil. But if you see the chemical or the physical property, the soil texture varies from sandy loam in the surface to clay loam. Subsoil horizons are extremely hard and compact when dry. Calcium carbonate concretion zone is commonly found below 80 centimeter depth. This depth causes physical impedance for root proliferation. And then have poor physical properties due to high sodicity and high pH. Low infiltration rate. Infiltration rate in these soils is very poor. अगर आप आज इसमें पानी अगर आप लगाते हैं तो उसमें पानी लगाने के बाद कम से कम नहीं तो 4-6 दिन तक उसमें खेत में पानी खड़ा रहता है. पानी, this infiltration rate is very poor. The soluble salt contain predominance of sodium carbonate and bicarbonate, deficient in organic matter, available nitrogen, calcium and zinc. So organic matter, these soils are very hungry, or you can say very hungry in organic matter. You can't believe that organic matter of this type of soil, where yes, you can see the pH of this soil will be 10.5 and the organic matter will be 0.0 or 0.08 or 0.06. So you can't imagine that these are up to what extent they are hunger in organic matter content. So now the municipal solid waste compost is maybe an important source of organic amendments. So that's why I started this study first time in the countries for the reclamation and management of salt affected soil through management of this solid waste. So the why municipal solid waste compost? Availability of FYM and vermicompost. Although there are other sources, but in required quantity is a matter of concern. Press mud, another source of organic matter. Press mud is the produce from the brick industries. No, sorry, not brick, sugarcane industry. The press mud, which is the byproduct of sugarcane industry, can be a good source of organic amendment because it contains high calcium also. So that's why it can be best for reclamation salt affected soil. But nowadays it is utilizing in brick kilns. So availability of it in the required quantity is a major concern also. Then microbial population in soil is reducing due to continuous use of chemical fertilizer and insecticides. You can understand very well that because they are divided, microbial population is reducing in our soils. And then nutritional value of grains, vegetable and fruit is depleting due to poor plant microbial relation. And then municipal solid waste is available in abundant quantity. This source is available in abundant quantity. So with this, we can utilize this for as. So for this, we initiate the study. This is experimental data. You people may be interested in this data or not, but I would like to share what study I have done and what was the impact of this study and how much the soil was improved, soil health was improved, grain productivity was improved, and the soil was reclaimed. And in addition to that, not only soil reclaimed, but our environment also protected with this best management of this solid waste. So I initiated this study. This was the experiment. You can see in this, we filled that mixture, that what I told you in my earlier slide, that municipal solid waste plus this agriculture waste, to make the compost with a certain treatment. They want this 100% municipal solid waste, 100% municipal solid waste plus microbes be added, and then 50% municipal solid waste, 50% agriculture waste, and then 100% municipal solid waste, then plus added earthworms, and then municipal solid waste plus agriculture waste, like that. These are the certain 7 treatments. So with this treatment, we started the on-farm composting to develop the protocol for on-farm composting protocol. Which will be the best treatment so that farmers can get cheap product, cheap organic municipal solid waste compost at his doorstep, or he can produce. So we culture what cultures we used: Aspergillus, Trichoderma, and Bacillus, and the earthworm species we used Eusenia foetida for this composting process. And you can we monitor the changes during this period. At 15 days interval, we monitor the temperature and the moisture. Then 15 days, 30 days, 50, 45, 60, 90 days, up to 120 days. Our total composting process it took 120 days. And reason behind this 120 days is much more. You can say this question, you can raise this question that it is 120 days means 4 months. But because we started this process during the winter season, so that's why it took more time. But if you initiate this composting process in summer season, then it can produce a good compost. It can compost within 90 days. So we can save about 30 days because of this during summer or winter. So this is the temperature, this is the moisture. We measured the initial moisture was very high in all the treatment, but when the time goes and then the moisture content depleted, and so improving. It's a symbol of improving the quality of composting. And monitor the changes in soil pH. If you see initially the pH in the pH was 7, and it increased. It increased up to you can say up to 75 days pH increase, but slowly when the microbial process or decomposition process start, the pH decreased. Similarly, the EC increased at 45 days and then start slowly reducing the days of composting. So this is we measured, and we measured the changes in CN ratio, CP ratio, CK ratio during the composting and different treatments. So if you see that the CN ratio, we discussed about CN ratio earlier. The CN ratio was very high, but in different treatment. But when the decomposition process continue and the CN ratio reduced, means in treatment T6 where we used the microbes and earthworm, both combination of microbes and earthworms, this treatment T6 gave very good CN, lowest CN ratio. So means it is good compost for utilization in the field. Now changing nutrient content, we also monitor. This is the initial nitrogen, and this is the final nitrogen. This is the initial phosphorus. This is the final phosphorus, and then this is total potassium, and then increase the potassium content, increase the phosphorus content, and then nitrogen content. The highest total nitrogen was estimated in the treatment T7, and the lowest in treatment T1, like that. So this was the effect of different treatment on nutrient status of our composting material. And then enzymatic activity also we monitored during the composting period. There's amylose content and this gyelinase content we also monitored at initial and 130 days, and at initial and 120 days. If you see that in treatment, different treatment, there was improvement in the property of our composting material. And now this is chemical characteristics of on-farm and industrial process. We compare our on-farm produce. This was our on-farm product. You can see the photo. There was the evaluation team of the project, evaluation team from this UPCAR, UP Council of Agriculture Research. They monitored our product. So this is our product. If you compare our industrial product, the industry means municipal solid waste treatment plant. They are producing the compost. And we compare so if you see the pH of that compost is 7.48, our pH is 7.636. pH is less, but the EC is less, total nitrogen is higher, total phosphorus is less, total potassium, this is non-significant, you can say, and total potassium is increased, and calcium content increased. And then you can say total carbon content increase, and then total CN ratio reduced. CN ratio in our treatment was less as compared to the industrial. So CN ratio is less. CN ratio means better quality of compost. So this was our on-farm composting protocol we developed in treatment T7, give the best results, best quality of compost. Now this is the microbial properties. Time, I have time. Hello.
Sir, yes, sir.
Hello. Should I continue? Time is permit?
Yeah, 20 minutes, sir.
20 minutes. Okay, sir. Okay.
Yeah.
So these are the microbial properties of our composting. If you see the initial properties, microbial bacterial population initially in all this treatment was like that, and then fungal population, and then phosphate solubilizing microbes population was like that, and then after 120 days when our compost was ready, then it was increased. In maximum was in treatment T7. The highest population bacteria, fungus, and phosphate solubilized microbes at initial and 120 days after composting was recorded in treatment T7, where the lowest in the treatment T1, T6, and T2 like that. This is because of depletion of nutrients, which is an indicator for completion of composting process. So our processing is complete and the microbial population is increased. So this is the comparative the comparison of initial status and then after completion of the composting. Now we also monitor the heavy metal content in on-farm compost. If you see the heavy metal content like calcium, magnesium, potassium, zinc, copper, manganese, and iron. You see the heavy metals like arsenic, cadmium, nickel, and lead are below the detectable limit in these samples analyzed through AAS. So, but the concentration of these heavy metals was below the detectable limits in our on-farm compost. We have not found any harmful heavy metal in the compost which we developed through on-farm composting process. Now this is the end product. This you can see this is our end product, and this product we took in the field. We applied this product in the field. So this is the composition, pH 7.36, EC like this, total carbon, or this is the total this calcium, total potassium, total phosphorus, total nitrogen, and CN ratio 17.13. The product which I have shown in earlier slide. This is our main product, and with this product we went to the field. And now you can ask the question, what is the cost of that your product? So earlier I have told that the compost which we are in the treatment plant are selling in the market is 250 per 5 kg bag. But in our product, the cost was only composting per kg 4 rupees 14 paisa per kg, or you can say 4 rupees per kg. And this 4 rupees, even if it can be reduced, the major cost of is the Burmese bed. You can see the Burmese bed. Its cost is about Burmese bed cost is 5 Burmese bed cost is 12,500 rupees 5 bed. So the cost, but we can utilize these, farmer can utilize these Burmese bed for at least 5 to 6 years, 5 to 10 years. Sometimes it can, it's a very good quality material, so farmer can utilize it for 10 years. If we calculate in this way the utilization for 10 years this bed, then cost will be very less. So farmers can produce this compost at his own farm. And now question is how much optimize the dose of solid waste, municipal solid waste compost. How the farmer will decide that how much he should apply in the field. So although it depends on the soil pH level, but if the soil pH is 9.2, we started our experiment. The spot experiment initially we started to optimize the dose, and the pH was 9.2, and the organic carbon was 0.48, and available nitrogen like that. This was the soil which we filled in the pot, and we conducted a study on this mustard and wheat crop. If you see the plant growth and yield of mustard and the plant height, 15 tons we applied in that pot control, where we have not applied any compost, and this is 5 ton, 15, 10 ton, and 15 ton per hectare on the like that. So the yield, grain yield was at the highest in case of mustard, 14.1 gram per pot. It was highest in the case of 10 ton per hectare, where we applied the municipal solid waste compost. And in case of wheat, The highest yield we obtained at 15 tons per hectare. So this was the optimized dose. So in case of 10 to 15 tons, you can say what the optimum dose for the to get the good yield with this municipal solid waste compost. Now we reach this, optimize the dose, and then we went to field experiment. We conducted field experiment for 3 years continuously. So where the field where we started the work on this utilization of municipal solid waste compost, the pH of that field you can see was 9.8, and ESP was very high, 78, and organic carbon content was 0.13. You can say the 1.3 gram per kg. You can say 0.13, and the available nitrogen is very poor, 30.68, and similarly P and K. And gypsum requirement, you can see gypsum requirement was 15.2 tons per hectare, like that. So this was the total composition of our soil, where we started the experiment in the field. You can see this was the field. This is the picture of that field where there was no any grass, or it was very poor soil, where pH was very high. pH was 9.8 pH. We initiated the experiment, and with these were the certain treatment. And you can see the imposition of treatment we imposed. This is our product which we spread, and before that, and this is the gypsum. We reduced the gypsum requirement. Earlier, our technology, our previous technology, available technology developed by our institute, the technology is 50% GR, means total gypsum requirement, 50% of the gypsum is recommended. But in this case, we reduced the gypsum requirement from 50% to 25% with the substitution of municipal solid waste compost. So this was the certain treatment. The gypsum, this is our recommended technology, and then phosphogypsum, another alternative we found, phosphogypsum with 50%, and then decomposed 10 ton per hectare municipal solid waste. We applied only 10 ton per hectare. The gypsum requirement 25% GR, 12.5% GR, and like gypsum and phosphogypsum repeated in such a way, we conducted this experiment in the field. And if you see the imposing of, this is the treatment, we spread the gypsum, and then organic matter we added, and then this is the protocol, then ponding of water for 10 days in the plots, and then mixing the gypsum in the plot, and this is complete protocol for reclamation of sodic soil. And now this is the chemical composition of phosphogypsum and gypsum. You can see in major concern is about calcium. In phosphogypsum it is 18.9%, and mineral gypsum 18.3%. So both the chemical amendment were at par, but so we tested this alternate also because of non-availability of mineral gypsum nowadays. But phosphogypsum is the product of the phosphoric industries, Paradeep Phosphate, like Paradeep Phosphates Limited, like that. The phosphogypsum is in large quantities available. This product is available where the phosphorus industries are producing the phosphorus. They are phosphorus producing industries. They are having large quantity of phosphogypsum. They are dumped. So we collected that, and we tried that this can be another source because of high calcium content equal to gypsum. And now on physical property, when after 3 years we evaluate the soil parameters, and you can see the soil, the bulk density, hydraulic conductivity, sand, silt, and clay. If you see the initial initial hydraulic conductivity of that field was 0.08, but with the addition of this treatment, the hydraulic conductivity increased, and similarly this sand, silt, and clay content also improved. And the bulk density, you can say bulk density, it was initially 1.59 on the soil surface soil, 0.5 centimeter soil depth, and it reduced to 1.57. Means there was improvement in soil physical properties also after 3 years of continuous cultivation of rice wheat with the addition of municipal solid waste compost. And now the chemical composition of, and now this will be the 3 years after soil chemical properties. If you see chemical property, initial chemical property was 9.8, but after 3 years, the pH reduced to 8.84 in this treatment, in this particular treatment. Means this is the impact of integrated combined use of reduced dose of gypsum and municipal solid waste compost. The pH reduced to this extent, the ESP, which was 78, reduced to 30, and in case reduced to 28 in treatment T4, and organic carbon, which was 0.13, it was 3.5, or you can say 0.35. Available nitrogen, which was only 34, it increased to 198 kg, like that. So these are the certain impact of this organic municipal solid waste compost on improvement of soil properties, chemical properties. Now come to the microbial properties. Also, after 3 years, we see the initial, if you see the bulk density, like that, cumulative infiltration rate, you see infiltration rate, which was only 2.10 millimeter per day. It increased to 18 millimeters per day after 3 years of continuous cultivation with the addition of this municipal solid waste compost. And bacterial population, which was 1.3, it increased to 5.5, and fungal population, which was 0.2, increased to 9 CFU per gram. So this is a significant improvement in soil chemical, physical, and biological property with the addition of municipal solid waste compost. Well, microbial properties, I have already told you. And this is the amendment: bacterial and fungal population, MBC, microbial biomass carbon, microbial biomass nitrogen, microbial biomass phosphorus, and dehydrogenase activities we also analyzed, and there was significant improvement in these properties also after addition of municipal solid waste compost in the salt affected soil. And now heavy metal content, if you see the heavy metal, the initial, it was cobalt 0.076, it reduced to 0.42, and like from 0.007 to 0.059, and 3.18 to 2.9, and 13.68, but increased. This iron content slightly increased from 13.64 to 28.53. Just please wait. Hello.
Yeah, sure, sir. No problem.
मैं अभी एक सेमिनार दे रहा हूँ. So this is our lead content and zinc sulfate. So the heavy metal content like cobalt and chromium were reduced over the initial value and found lower than the permissible limit. However, lead increased over the initial value but below the permissible limit ascribed by Sultanpur and Macanata. It was even this iron content increase, but it was within the permissible limit. And the organic carbon buildup and nitrogen retention after 3 years of reclamation. Organic carbon buildup, you see, after 2 years, the organic carbon percent was 0.35, and enriched it was 0.06. It was increased in terms of enrichment, and similarly available nitrogen increased to 100 kg per hectare. It increased over the initial value. And now crop growth. So I think you might be interested in crop yield. If you see, these are the certain parameters which we collected: the plant height, panicle density, dry matter. This is rice crop and wheat crop. So I think no need to explain. But you come to the grain yield. If you see the grain yield increased significantly in case of treatment T3, where we applied 25% gypsum plus 10 ton per hectare municipal solid waste. The maximum grain yield of rice, but in case of wheat, where we applied 25% phosphogypsum, T4 means where we applied reduced dose of phosphogypsum with 10 ton municipal solid waste compost, the grain yield was higher in 2.4 ton in this treatment T4. So with the crop where there was no crop, nothing was there, and with the addition of this municipal solid waste, we increased the crop yield. And this was the cost calculation: cumulative net return and benefit cost ratio of rice wheat cropping system with organic and inorganic amendment. If you see, the small positive net return was obtained with treatment T6, where reclamation cost was very less due to addition of very small quantity of gypsum. This, although it was, but where 12.5% GR gypsum was applied and 10 ton per hectare press mud, this gypsum was applied. And however, net return was negative in all the remaining treatment. And in case of positive BC ratio during first year, benefit cost ratio, reclamation followed by rice wheat cropping system. So we can say that overall, if you see the nutrient concentration in wheat and grain, maximum nitrogen concentration in rice grain was recorded in the treatment T4, and whereas the highest nitrogen concentration in straw was observed in treatment T3. So we can say wherever we apply the organic amendment in conjunction with reduced dose of gypsum, the all the parameters, nutrient concentration in grain and wheat, grain and the straw, and the soil amendment or soil improvement, this overall effect, it was good to add the utilize the municipal solid waste. So at the end, I can conclude that the combined use of municipal solid waste with agriculture waste for composting is an alternate option to municipal solid waste management. And the municipal solid waste compost prepared through on-farm composting using 50% municipal solid waste plus 50% agriculture waste enriched with earthworm and degrading microbial strains product nutrient-rich, cost-effective quality compost. And third one, the sodic soil treated with on-farm municipal solid waste compost at the rate of 10 ton per hectare in conjunction with reduced dose of gypsum or phosphogypsum has been successful in improving soil physicochemical and biological properties and sustaining crop productivity compared to the addition of gypsum or phosphogypsum alone. Adoption of this approach will save 50% gypsum requirement without significant loss in grain yield. With the introduction of this technology, about $43 per hectare may be saved on account of reducing gypsum at the rate of 25% GR by using on-farm compost, industrial process municipal solid waste compost, and sustained crop productivity in degraded sodic soils. So this is overall about my work and my results related to the management of both, you can say, reclamation and management of salt affected soils, as well as best use of this dumping material, this municipal solid waste, for converting it into compost and then used for the reclamation of salt affected soil, because India is having large 6.73 million hectare salt affected soil. So this can be a good source of organic amendment for the reclamation of the salt affected soil, and it can help to boost the organic farming in the country, because sodic soils, they are totally virgin soil, you can say. And if you start the application of organic amendment in virgin soil, that is totally 100% organic initiative, because they have not we have not applied any chemical in those soils which are totally virgin or unused or unproductive. So from the very beginning, we can use the municipal solid waste compost in those soil and promote the organic farming also. It will to manage the another point is that we can add the food in our food basket. Otherwise, these lands are barren, unused, and unproductive. So we can say that is the multi-use of this municipal solid waste for reclaiming and saving our environment, our human health, and our you can say our biodiversity also. So with these words, I'm thankful to Dr. Abhishek ji once again, and thank you very much.
Yeah, thank you so much, sir. And now it is open for any query or any questions from anyone in the participants. So you can ask to the sir. Yeah, Kalyani ma'am.
Yeah, thanks, Abhishek. If I can ask a question, but I was actually waiting if the students wanted to ask something. But anyway, I guess I will ask. Right. Sir, it was a very nice account. I mean, where you have tried to use your knowledge with the CSSRI and the municipality, concerns, whatever. But I just have one query. When you say you segregated the municipal waste, was it segregated in terms of was it segregated in terms of the municipal waste segregated into the biohazardous waste, that is the hospital waste and other things, or how was it segregated? I just wanted to know, because I just
I was expecting this question.
yes,
Because segregation is a big problem in municipal solid waste.
absolutely.
But I of course I managed it. I segregated in our experimental purpose. We manage the segregation through manually, degradable and non-degradable. But nowadays, government is emphasizing, or municipal corporation on not only in Lucknow, maybe your city also, they are putting separate bucket. They are collecting the material, the degradable and non-degradable material in two chambers in our Lucknow city. So now it has become easy to collect the segregated and non-segregated material. But in my experiment, where we started in 2000, you can say 2017, we started work on this aspect. So at that time, we collected a full truck of from the dumping yard. I requested personally to municipal authorities, and they give me one truckload and dumped it on my farm. Then I put the labor and segregated it. So for the experimental purpose, but nowadays it is easy to get it.
Thank you, sir. I have just one more doubt. Like you said, the segregation is now on the agenda of any municipality, that they have to segregate the waste into the biodegradable and non-biodegradable. But if there are categories in the biodegradable, non-biodegradable also, which we are still not following, to the standards of, let's say, the European countries. And also, like you say, it is in theory it is done, but in practice it is still not done. That's what I'm saying. Even in Delhi, in practice, the segregation is not done. It should start at the source, at a household, in a house, but it doesn't happen. So that is one thing. Probably people like you can force the governments to have a look at it again, because you people have the know-how. And one more doubt, sir, about the biogas production. You have not emphasized on it, but I have a doubt that for the biogas production, many years ago, biogas plants were set up in many places in India, but they failed because there is no follow-up action on biogas. Do you think there are some people who need to be trained so that they can set up the biogas plants and see that they continue to function? Then probably it will be useful.
You are absolutely right. But I want to give the example of this municipal solid waste treatment plant at Kanpur, that named as A to Z plant. Company name is A to Z, and they are making many more things from that municipal solid waste. They are converting it to pellets that for fuel purpose, and they are generating energy, electricity also. And initially, before establishment of the electricity generation, they were having their biogas plant. So they are producing the biogas and giving to the surrounding company was doing. Farmers were not doing, but company was generating the biogas, and they are distributing to the nearby residents that free of cost. So that just to utilize that product. So this was this can be another enterprise, or you can say another source of best utilization of the management solid waste in future also.
Thank you so much, sir. Thank you. Thanks a lot.
Welcome.
Thanks, Abhishek. Thank you.
Yeah, any other questions? Oh, okay. I think there is so many questions, but if you can ask later on. And thank you, sir, for your enlightened and the viable lectures. And you are accepted our invitation. It is the pleasure for us.
Welcome.
Yeah. So
no problem, sir. Thank you very much.
Sir.
Welcome.
And one more question is coming from the Subhankar. You can ask. And after that, I will request to the Dr. Sunita Yadav to give a formal vote of thanks. So, Suvankar, you can ask the question.
Hello. Yes, sir. Am I audible?
Yes, please. Yes, please.
Okay. Actually, sir, thank you, and thank you, ma'am, also, because I was having the same question about segregation of the waste.
Please speak loudly. Please speak loudly.
Hello, sir.
Yeah.
Okay.
Yeah. Yes, okay.
Actually, thank you, ma'am, and thank you also, because I was having the same question about segregation of the waste in your work. But we know that in different areas that their municipalities are giving two buckets, whether one is biodegradable and non-biodegradable, but people are not following it properly because of lack of education or something, I don't know, because they are not following it. Actually, sir, I have a question that if we collect only vegetable waste in a form of biodegradable waste and collect it and that use it as a as a organic fertilizer in surrounding agriculture land, is it feasible or is it okay?
Yes, it is feasible. It can be if any startup, if any person like agriculture graduates or graduates, if they started this in the form of a startup, they collect the only vegetable or fruit degradable material and convert it into compost. They can even they are doing many students, many people are doing. They are using this degradable waste for even for vermicompost also, making the vermicompost, and they started their entrepreneurs. And friends, dear, your good name, please.
शुभांकर नाहा.
शुभांकर जी, मैं आपको, अगर आप हिंदी समझते हो तो बताऊं कि मैं अपने पिछले 10 साल से मैं अपने घर का, जो मेरे घर पर मेरी वीडियोज अगर आप कहेंगे तो मैं आपके साथ शेयर करूंगा. आई हैव
सर, अगर मैं इंटरप्ट करूं तो अगर आपके पास कोई अभी वीडियो अवेलेबल हो तो आप अभी भी प्ले कर सकते हैं.
नहीं, यहाँ तो वीडियो नहीं है, वीडियो यहाँ इसमें नहीं है वीडियो, बट मेरे उस पर है, यूट्यूब पर है. तो मतलब मैं अपने घर का किचन वेस्ट पिछले 10 साल से किचन वेस्ट का मैं अपने घर पर कंपोस्ट बना रहा हूँ उस पर, और कंपोस्ट बना करके मैं अपनी रूफटॉप गार्डनिंग पर मैं सारी सब्जी throughout the year, whole year I'm getting the vegetable on my rooftop gardening with the utilization of my kitchen waste. So nowadays in Lucknow, on TVs and radios, many people, my neighbors in my colony, all the time they are coming and seeing and replicating that program in my colony also. Many people have adopted my technology and they are using that kitchen waste for composting and rooftop gardening.
Yes, sir, it is very good. Actually, sir, if we quantify the amount per capita, that is huge. That's why I'm saying this. We can use it in agricultural land.
Pardon?
Actually, sir, I was talking about that the quantity. If we quantify the amount per capita wastage, vegetable waste, that is huge. That's why I'm talking about this. That we can use it.
Yeah, that's good. Yeah, you can use it.
Yeah. Thank you, sir. And please share that video, sir.
Okay. You give me your mobile number and I'll send it my videos on your mobile. No problem. You just note down my contact number and then you say hello and I'll send you my videos to you on your video. No problem. 730
730
956.
Okay, 757.
730 956.
730 956.
3010.
3010.
Yeah, thank you.
Okay.
Thank you very much.
Okay, thank you so much.
Thank you very much, Suvankar ji. Thank you very much once again, Abhishek ji and madam.
Yeah.
All
Thank you.
Organizers.
Thank you so much, sir. I would
my best wishes for grand success of your seminars.
Thank you. So I would here propose a formal vote of thanks. Halaki, we have seen almost many of our participants, they are very enthusiastic and they would like to hear more from you, sir. So we would like to have you some other time, maybe where we have more time to interact with you. And it is my privilege and honor to propose the vote of thanks to Dr. YP Singh. We are honored to have you, sir, here in this 3-day online course. And you have grasped a very important topic in the current area, the solid waste management. And you have very actually, inculcated, or you have, put the seeds in the minds of young participants about like how they can work on this area in the future and help the society in achieving, better goals and sustainable crop productivity. So thank you so much, sir. And thank you again. Thank you. Thank you, sir.
Yeah, thank you so much, sir.
Thank you, Doctor.
Yeah. And because this third session is already completed, so we will take a break and we will reassemble at 2 p.m. at the same link for the fourth session. Okay, thank you, everyone.
Thanks, Abhishek. Bye. Bye. Bye, Abhishek. Bye, Sunita.
Bye.
See you, ma'am. See you at 2, ma'am.
See you at 2. Right. Abhishek, I'll give you a call, Abhi.